Hi there! In this video we're going to talk about direct variation. So it's kind of a trick to direct variation. The trick is, this is something that you've already learned before. Direct variation is pretty much exactly the same as y equals mx plus b, but the b is always 0, and the m, the slope, instead they don't call it slope, they call it constant of variation. Other than that, it's everything that you've ever learned about y equals mx plus b. The slope is not allowed to be 0. So mathematicians write it like this. They either write it like y equals kx, where k represents the constant of variation, or some textbooks use y equals cx. I've even seen some textbooks that say like y equals ax. The thing that you need to know is the value, that's next to the x, whether it's k or c or a, is the constant of variation, which is really just the slope. Okay, and so when you read this, y equals kx or y equals cx, you say y varies directly with x. Notice there's no constant of variation in there. When you see this phrase, varies directly, that implies that you have a constant of variation. That implies that you're going to have a k or you're going to have a c next to the x. It's going to have some sort of slope. So there's basically like 3 kinds of problems that they can give you in relation to direct variation. So I wanted to go over like all 3. So the first kind are, do the equations below represent direct variation? And if so, what is the constant of variation? So in order to tell if it represents direct variation, we want to write it like, can I write my equation like y equals kx? So I need to take my equation and I need to solve it for y. Remember, I want to solve for y. I want it to look like y equals mx plus b. But with no b, I just want it to be like y equals kx or y equals mx, something like this, okay? So on this first one right here, I'm drawing my line around down the middle of the equals. So whatever I do to one side, I do to the other side. Remember, I have to get y on the side by itself, so I have to move this 4x, and I have to move this negative 5. First thing I'm going to move, negative 4x. 4x. And to do that, I'm going to subtract 4x from both sides. This goes away, so I end up with negative 5y equals negative 4x. Now I have to get the y on a side by itself, so I have to get rid of this negative 5. Remember, this says negative 5 times y, so to undo times or to undo multiplication, we have to divide. So I'm going to divide both sides by negative 5, and I end up with y equals, now, negative 4 divided by negative 5 is positive 4 over 5x. This is my answer. Does it look like this? Is it y equals some number times x? It sure is. So what's your constant of variation? 4/5. And yes, this is direct variation because it looks just like this. Okay, let's try the next guy over here. So I need to get y on a side by itself. I have to move this 2x, and I don't have any number next to y. So this is a positive 2x. To move it to the other side, to undo this, I'm going to subtract 2x from both sides. So I get y is equal to negative 2x plus 1. How did I know it was plus 1? Because this is a positive 1 right here. Okay, does this look like y equals kx? No way, Jose, it does not, because look at this right here. I have a plus 1. That plus 1 indicates that there would be like a b value, and we're not allowed to have that. So this is not direct variation. No. So remember, we only want it to look like this, y equals kx or y equals mx. So that's the first kind of problem they can give you. Second one is kind of more like a story problem. It's going to say y varies directly with x. That's that whole mathematician thing I set up here, how they describe this equation. Y varies directly with x. If x equals 3 and y equals 9, Find y when x equals 7. Okay, so let's kind of break this down a little bit. I wrote out some steps for you on the side. First, write out your equation. This part right here, y varies directly with x, tells you your equation. Tells you, looks like y equals kx. Okay, that's my step 1. Substitute in the values given for x and y. If x equals 3 and y equals 9, we're going to stop right there. That's this step right here, step number 2. We're going to plug these in. So if x equals 3, so x equals 3 here, and y equals 9. Okay? Check. And actually, I'm going to have the step be in pink so that it matches what I wrote. Style pink. Okay. Step number 3, we'll do an orange. This guy right here. Solve for k. Okay, I have to get k on the side by itself. So really, remember, this says 9 equals k times 3. So, how do we undo multiplication? We divide. So I'm going to divide both sides by 3. So 9 divided by 3 is 3. So I get k is equal to 3. Okay, write out the equation with the k in it. So this one I'm going to do in black right here. So my equation now says y equals 3 times x. Perfect. And then last but not least, we'll do in purple here. Find the unknown variable with the other given value. So find y when x is equal to 7. So that means I don't know what y is, but where I have an x, I'm going to substitute in a 7 and multiply this out. So I get y is equal to 21. So my answer is y is equal to 21. Okay, now they can give you a story problem like with a context in it that talks about, I don't know, something increasing is in terms of something else. You can talk about like salt water in a fish tank. You could talk about, I don't know, a whole bunch of different ideas that would relate to each other about something increasing, about the amount of hours worked and the amount that you got paid. Those are going to be things that vary directly. So they can put a story problem in context like that, but this is the gist of how they all work. Okay, and last but not least, we have graphing of direct variation. So they're going to give you a couple of graphs, and they could say which one of these graphs represents direct variation. Remember, direct variation has a y-intercept of 0. So I want to look at each one of these y-intercepts. Here's my y-intercept on this graph, and here's my y-intercept at this graph. Which one of these graphs is it at 0? This one right here. So the one on the left is going to represent direct variation because it crosses through the origin. If it doesn't cross through the origin, not direct variation. That about sums up direct variation. If you have any questions, please let me know. Good luck.